Hello, everyone. Thank you all for coming to the session. Today, we have a session on building serverless websites with LambdaEdge. We really appreciate you all being here, especially considering that yesterday night we had the reInvent replay party. So thank you all again. My name is George John. I'm a product manager in the LambdaEdge team. And with me, I have Mani Radhakrishnan. He's a senior software engineer in the CloudFront LambdaEdge team. Before we get started, I just want to get a housekeeping item out of the way. Both myself and Mani will be hanging out here after the session, so feel free to stop by if you have any questions. So over the next 60 minutes or so, we want to walk you through a scenario where we start off with a fully hosted website. We'll deconstruct it as we go along, and finally get to a state where the same site is now hosted in a serverless manner at an edge location. And as we go through the evolution, we'll discuss why it is beneficial to run websites at the edge. We'll take a look at some of the key functionalities and capabilities of Lambda at the edge. And we'll discuss various use cases. We'll share some code samples in terms of how you could build functionalities that are part of any typical website, how you could do or how you could run that in a serverless manner on the edge locations. So just imagine that you had a great breakthrough idea. Now, it could be anything. It could be that you found a new way to curate news, real versus fake, or you had an idea of how to do social media in a different way, or do some predictive analytics. I think for the purposes of our presentation, our goal is to look at some of the common functionalities that any website might need, and let's see how we can implement that in a serverless fashion with Lambda at the edge. So the next logical step is, so you have this idea, now you want to go build it, right? Typically, you want to try it out, you want to validate it. You decide to build a MVP, a minimal viable product, and you want to make sure you're able to iterate fast, be agile, go build something or take something to the market pretty fast. And you want to be cost effective, and you choose AWS as a platform. So this is the scenario, and we'll see how we can evolve this. So again, we just chose a news aggregator as an example. It could pretty much be anything you want, because the functionalities we're going to discuss applies to multiple sites. So typically, if you look at any website, there's going to be some content that is static, that doesn't change, that can be cached. So things like the images or media, the client-side JavaScript, the HTML, the CSS, all these don't change that frequently, and those can be cached pretty well. And then you have the dynamic content, right? So in this particular example, it would be the top news or feed that's pretty dynamic, that keeps changing. Then you have another type of dynamic content which is very customized to the viewer, right? So depending on where the viewer is trying to access, in this particular example, a news aggregator site, depending on where the viewer is, you want to show maybe the local weather. Maybe in the local news, you want to show very Vegas specific. So let's say the viewer is coming in from Las Vegas. You want to show him news which is very customized to that particular viewer. So this is an example of customizing it based on the location of the viewer. It could be customized based on the device the viewer is coming in from. So if the viewer is coming in from a mobile phone, you might want to crop the images or have the images appear in a different resolution as opposed to the viewer coming in from a desktop. And then typically, if you look at any site, there is some sort of way for your end users to sign up to provide their preferences. So in this particular example, it could be that the user is only interested in, let's say, sports or business or certain type of news or topics. So he could make all those selections as part of his profile once he logs in. And he could also make selection like, what language do I want to see my site in? All right, so we're not going into the nitty-gritty details of how the different components are connected. But typically, when you talk about any site or application, you have a compute component. It could be an EC2 instance. It could be containers. There's a storage. So in this particular example, your website, you have a lot of static content. So your images, your CSS, all these can be stored in a storage. It could be an S3 bucket. Then you need some sort of data store. It could be a relational or non-relational database. And in your particular, going back to the previous example, your users sign up, what are their credentials, what are the selections, all those information can be stored in the data store. Now, zooming out a little bit, let's say you chose US East 1 or North Virginia region as your region. And you can see that all the compute, the storage, the database, they are all located in that origin. And that works fine, right? When you are very early on in your product development phase, you have a couple of users, maybe your friends, families, maybe a few people who are interested, and everything is OK. At this point, your real goal is to validate your idea. You're iterating over it. You're trying to find the right market fit. And then let's imagine that you are successful, right? You hit the growth phase. Now you have users not just from US, you have users from across the globe who's trying to access the same, or trying to access your website. And soon you would find that the performance is not great. A user, for example, who's coming in from Australia now has to go all the way across to hit your origin, which is in US, and the kind of page load times or the kind of responses he or she sees could be quite different from a user who's very local, who's close to your origin in US. And you have a new set of challenges to now worry about. One of them is you need to scale your infrastructure to meet the increased demand, scaling the infrastructure. And you want to scale in such a way that you can still manage the operational overhead or complexity. Remember that you are still a pretty small shop, so you don't have a lot of people, so you want to be able to manage the infrastructure, but at the same time, you want to scale to the limits you want. And you still want to provide the same good user experience, irrespective of where your users are coming in from. You cannot discriminate a user who's far off from your origin versus a user who's pretty close to where your origin is located. And you want to provide the same rich set of capabilities to all users. And the good thing is that AWS today has services that can help with these. So Amazon CloudFront is a CDN, a content distribution service from AWS. So you can use CloudFront to essentially cache a lot of the static content, and we'll talk more about that in a bit. And then you have AWS Lambda. So Lambda can help address the scaling challenge we talked about before. It can help the operational overhead challenge because Lambda is serverless compute. And at last Reen, when we really announced, we announced a service, LambdaEdge, which is pretty much an amalgamation of the capabilities of both CloudFront and Lambda. And that's LambdaEdge. It was in preview at last re:Invent. It went GA early this year. So a quick look at CloudFront. So CloudFront is CDN, like I said. It's got 107 points of presence or POPs, and we keep adding on to the list based on customer feedback we get and based on where the users are coming from. So here in the map, you can see all the locations we have. And a POP can be an edge location, or it can be a regional edge cache. Now, edge locations are a global network of data centers that CloudFront uses to cache and distribute the content to viewers wherever in the globe they may be. And then the other thing we have here is regional edge caches. These are mid-tier caches that sits between an edge location and origin. And these are available to you at no additional charge. You do not need to change your application to make use of them. And if you look at the map here, you can see the regional edge caches are located in AWS regions, meaning that we have a lot more capacity available to us, which translates to a CloudFront customer having more cache width and better cache hit ratios. Now, going back to the architecture, right? Introducing CloudFront to the mix is pretty straightforward. You do not have to make any changes to the application. So now, CloudFront comes into the mix. This is not the full set of locations we have. For simplicity, I just selected a few. And then now, when the viewers, the same viewers who are trying to access your site, they're now not going directly to the origin. Instead, CloudFront would redirect or route the request, the HTTP request, to a location that's closest to them from a latency standpoint. So we have latency-based algorithm. We are constantly looking at how the internet is behaving. We're building all these metrics which we can use to send the request to the best, most ideal location from a latency standpoint. And the other thing is that if you look at the origin, we had the 3 icons there. We had the compute, the storage, and database. And now with CloudFront in the mix, you can extend your storage to the edge. So going back to your site, all your static content can now be located closer to the viewers. So what is the benefit to you? Why do we want to do that? So if you look at the, let's say going back to the scenario, you have a user in Australia who's trying to access the origin. Now CloudFront would automatically route the request to a location that's closest to him. So let's say somewhere in Australia. And since the content is very cacheable, it's not dynamic, the request can be immediately served from that location instead of backhauling it all the way back to the origin in US. Just moving on to what we had. So the static content now, it's all served through CloudFront. So the color scheme is, it was red initially if you notice that, but now I changed to green because all these static contents are now being cached at CloudFront. They're closer to the viewers, meaning that when they try to load their site, those requests can be served pretty fast from a location closest to the user. Now, the dynamic content, it's not green yet, it's not red, it's better than where we were before, just by introducing CloudFront to the mix, because CloudFront, over the last several years, it has been in existence, has been adding capabilities, not only for accelerating static content, but also for dynamic content. So we do things like various network optimizations, whether it's at the TCP level. If the origin is in AWS, we leverage Amazon backbone network. We use persistent TCP connections. Your SSL terminations from the viewers can now terminate at a location closest to them. So all these helps with accelerating the delivery of dynamic content. So later on, we can see how we can change those yellow into green. But this is where we are right now just by introducing CloudFront. So you have kind of moved some of these functionalities to the edge, mainly the storage. A quick look at Lambda. So Lambda is serverless compute. Essentially, you can run a piece of code without the need to provision, configure, or manage servers. It's event-driven compute model, meaning you provide a piece of code you want to run, you provide, or you specify when it should be executed. So you specify the trigger or event point. And Lambda takes care of running it on your behalf. It scales automatically with usage. So now you do not have to ask questions like, hey, do I have enough capacity for the next 6 months? Because going back to our scenario, you're at the scaling phase, right? So one of the good things about having Lambda in the mix here is that it can help with scaling, because that's something kind of abstracted away from you. With Lambda, you don't pay for cold idle servers, especially when you're a small company, or going back to a scenario, he doesn't have a lot of resources, so he wants to make sure he's paying only for the resources he's consuming. With Lambda, you don't pay for cold idle servers. You only pay when the compute is being executed. And with Lambda, there's built-in availability and fault tolerance. So now you do not have to be a distribution systems expert, because all that is kind of abstracted away from you. Lambda does the high availability and fault tolerance for your website. So now Lambda at the edge. Lambda at the edge is really an extension of Lambda, so all the capabilities, all the benefits we talked about with Lambda is also applicable here. But in addition to that, a key benefit is the global distribution. So Lambda functions that are not part of Lambda at the edge today run in a single AWS region. Now, Lambda is available in all AWS regions, so you, as a customer, you can choose the region you want. And that works perfectly fine for a lot of the use cases. But with Lambda at the edge, these functions are not just running in a region, but we make it available in multiple locations worldwide. Now, that is cool, that is good, but what is the real benefit to you as a customer of Lambda at the edge? So let's take a deeper look into that. Today, Lambda functions that are part of Lambda at the edge needs to be authored in US East 1, which is North Virginia. You have the same experience as AWS Lambda. There's nothing different. The only difference is that the hook or the trigger for your function is CloudFront. So once you click submit, what happens is the functions are automatically replicated across multiple locations worldwide. So this means that the same way CloudFront was able to move the storage to the edge locations, Lambda is able to move the compute to the edge locations. So now let's go back to the scenario. Let's say you had a user from Australia, and let's say he's making a request that requires some sort of compute to happen, so it's not really a static content. Prior to Lambda at the edge, the request had to travel all the way back to the origin, and then the response had to be served. But now, since the compute can run at a location closer to the user, the request can be served immediately. So now let's take a look at a deeper look into Lambda at the edge. Let's take a look at some of the code samples. Let's take a look at how you can implement the rest of the functionality with Lambda at the edge. For that, let me invite Mani on stage here.
All right. Thank you, George. Hope you guys can hear me clearly. My name is Mani Radhakrishnan. I'm a software engineer with CloudFront and Lambda at the Edge. And I'm here to talk to you in a little bit more detail about how some of the stuff that George pointed out as part of the website that are not quite being done at the edge can now be done with Lambda at the Edge. Before we dive deeper, let's take a look at what happens in an edge location when CloudFront gets a request. So what you see here is request lands at a CloudFront cache. A CloudFront cache is kind of a big blob in this picture. It's a little bit more evolved than that, but for our purposes, we'll just treat it as a giant cache. So we look it up in cache. If it's in cache, we serve it from there. There's a white line there that's not quite visible, but that's the traversal through the cache, and viewers get their response. But if it's not in cache, then we reach out to the origin. We know which origin it is because you have configured it a certain way, and then we get the content from there, maybe cache it if it's cacheable, and serve the response. What we've done with Lambda at the Edge is introduced a few points at which customers can customize the request processing in some ways. What that means is, say for example, we've introduced a viewer request event. What this allows customers to do is take a look at the requests as they come in the door, even before we start processing it, meaning looking in the cache or whatever, and modify properties of the request if they so choose. Similarly, there's an origin request event. What this allows customers to do is modify a origin request, meaning it's a miss in the CloudFront cache, and we are about to reach out to the origin, and you want to change something about this request. And yes, you can do that now. Similarly, as we receive a response back from the origin, we can modify that before that gets into cache, and the final one, right before it leaves CloudFront to go back to the viewer, you can change properties of that response. So essentially, 4 points at which you can modify. And based on your use case, you can decide which is the best place to implement the logic that you want to implement. And we will look at examples that hopefully will give you some ideas of when to do what. So a little bit of a deeper dive into the programming model. The Lambda at the Edge programming model is very similar to Lambda's. It's event-driven. What that means is functions are associated with events. These functions are obviously invoked when these events happen. The functions are invoked with the details of the event as input. And optionally, functions can return a processed result back to the caller. For Lambda at the Edge, let's take the example of the viewer request that we saw before. So we would associate a viewer request with some function that you have in my function. The colon 1 is actually a version. Lambda at the Edge expects that you always associate a version of a function. And if and when CloudFront receives a request, it would invoke this function. And this function would be invoked with the details of that request. Say you want to modify, or say you want to add a header in there. Now you add this header, and then you return this modified request back to CloudFront, and CloudFront will continue processing this request as though it's the request that got from the viewer. Nothing changes in what CloudFront does. You just get to peek into the request, change something, and let it proceed. This is probably how it would look in code. The top line there is the way it gets invoked. The function typically takes 3 parameters, an event, a context, and a callback. The event is the one that has the details of the event. For CloudFront, for example, if this is a viewer request event, then the request object is present as part of event.records of 0, because we always only invoke with 1 request at a time, .cf standing for CloudFront, .request. If it happened to be a response event, it would be similar, except that it would be event record 0 cf response. And so you could access the request or response that way, and then once you're done processing whatever it is that you want to do, then you call back with either the request or the response, depending on your use case, and then CloudFront will take the object that you return. The callback is the mechanism for you to return a result back to CloudFront. CloudFront will take that thing and continue processing. Cool. So pulling back, George alluded to how LambdaEdge can help with this customization, and that's what we'll continue looking. Broadly, I've classified, mostly for the purposes of this presentation, the customizations into 2 broad categories. One that's not personal to the user in the sense that you are looking at attributes that are not just that user, but something about them, the place that they may be in, or the device that they may be using, or the user agent that they may be using. And all of these are good reasons to customize, right? So you want to give them some local updates, or maybe change the layout of your website based on the device type, or like George mentioned, the images could be provided at a different resolution or cropped differently. All of those are good reasons to customize that are not quite personal to the user. And obviously, the second category is personalization based on who that user is, where you know something about that user. A, you know who that user is, and B, you know something about that user, and you combine these 2 things to create something that's more meaningful, richer for them. And another dimension on which things may vary is your particular setup. Say, for example, you are an existing CloudFront customer, and you're already using a CDN, and you already have a setup where there is a CDN plus an origin. And for now, you want to do things, but you don't want to disrupt this as much, and that's great, which is fine. So LambdaEdge can help with an origin-based setup just as much as it can help with the serverless setup. And so if you look at it, the first kind of customizations that publishers often look to do is using the CloudFront cache, meaning you have content that's highly cacheable. So if you have the same image at different resolutions, both images are equally cacheable. It's just that you want to serve one image to a mobile device and a bigger, larger, higher resolution image to a desktop device. So you typically want to use the CloudFront cache. And in these cases, this applies to both origin, with origin and serverless setup, because it doesn't matter where the response is produced, it's in CloudFront cache. And as the request comes in the door, you want to decide which of these 2 to serve, or which of these n ones to serve. And there's many ways you can do it. One of the common ones by modifying the URL, but you can just as well achieve the same result by changing a header or query strings. The second one applies a lot more to people or publishers with origins. This is the origin selection logic, which we introduced like 2 weeks ago. What this allows you to do, and it's mostly applicable to the origin request event, where right before the request gets out or is called out to the origin, you get to select which origin to send to, and you can dynamically change this logic. We'll see examples of why this may be beneficial, but this is a facility that mostly applies to the setup with origin. And the third one is generating content at the edge. This is mostly a serverless use case, mostly because here you're generating the entire response in one of the events that we have, typically a viewer request event or an origin request event, and you don't reach out to the origin at all. Cool. With that, let's start off with the CloudFront Cache-based examples. So in this, I just wanted to mention that for a variety of reasons, publishers may not have access to some of their client-side customizations. So I've picked examples where, or it may be beneficial sometimes to make one call from the client, do a few things on the server side, and then send that response back. So in my examples, I've specifically picked use cases where all the clients call out to the same object, say in this case, index.html, and then internally on the server side, which includes both LambdaEdge and your origin, you decide which combination to serve to that particular viewer. So for example, so if you want to vary based on viewer country, one way to do that is you inspect a property of the request and then change the URL. So you could include a path prefix that's the country, AU or UK or DE, whichever way you want to set it up, and then that internally would redirect. So let's say you do it in the viewer request event, you change the URL, now you look it up in CloudFront Cache with that modified URL, and then you serve that, either if it's a customer from Australia, they get the AU/index.html, and customer from UK gets the UK/index.html. Similarly, if you have a use case where you have multiple domains all served from the same distribution, but the content varies, you can do that by looking at the host header, maybe include that as part of your URL. The third way to do it is based on device type. You can take a look at the CloudFront is mobile viewer or CloudFront is desktop, those headers, and then modify your URL accordingly. These customizations, not just for the request side, it can be done quite as well for the response side. Here are some examples where you can include security headers right before the response gets generated, like HSTS or CORS. You can modify the cache control headers. This is one use case where if you have a lot of objects already in cache, and for whatever reason you want to control their cache control, you can do that in a viewer response right before they go out. This is an expose the true client IP is yet another one that we've heard from customers where you look at the X forwarded for and include that as a header that the origin understands in the origin request right before it goes to the origin. So these are some examples of how you could use the CloudFront Cache. And let's take a look at a deeper look at a particular one, which is using the device or modifying it based on the device type. In this case, I'm choosing to run this logic in the origin request event. Here, that means that I've already looked in cache. It's not there in cache. I look at the request and then decide, OK, so this one's a mobile viewer, and then add the /mobile into the URL, and then send that request out to the origin. Because my content is highly cacheable, I'm doing it this way. If that's not the case, you can just as well do this in the viewer request event. One thing of note is that if you do it in the origin request event is that you want to make sure that whatever headers that you're looking at are also part of the cache key. CloudFront has facilities to do that. It's called forward headers. Make sure that's part of the cache key, and forward headers will get you there. So looking at the code, the ones in blue are mostly things that we've talked about before, like how the function gets invoked, what it gets invoked with, how to look at the request, and how to return stuff back. The stuff in orange is the one that's more interesting to us. In this case, I am looking at the CloudFront is desktop viewer or CloudFront is mobile viewer, and I'm appending or inserting the right prefix or right desktop or mobile keyword in there. And that gets me to redirect and fetch the right, not redirect, just go straight to the origin with different URLs and fetch the right content. Cool. So now let's switch back a little bit and see how origin selection can help. So in this case, your customization's still mostly happening at the origin, but for a variety of reasons, you want to select which origin you want to send to dynamically. Sometimes it's because you have many origins that probably are identical, but are geographically distributed. Or maybe that you want to have multiple origins for redundancy and you want to load balance across them. It's doable with this origin selection logic. Sometimes it's a controlled rollout. So you want to introduce a new feature, but you just don't want to go deploy it all over the place. You want to do it in a more controlled fashion where you have parts of your origins updated, the others that haven't been. It could be blue-green deploys or A/B testing. That's doable. Sometimes it's migration across origins, sometimes including on-prem to the cloud. That can be done with origin selection. And we've heard this from customers where sometimes crawlers are not good at following or doing JavaScript. So you may prefer to just give them a pre-rendered version. And so you could detect whether it's a crawler or a real human being and then send them to an origin accordingly. The way you do that is this logic only runs in the origin request event. In this example, you have origins A and B. And as the request comes in, let's say one of the things that you want to do or make sure that you do is if a user starts being sent to origin A, then for the duration of that session, they probably want to continue going to that same origin. So a common way that people achieve this is using some form of cookies. So you start off by looking for the presence of the cookie. If it's there, then you know that a selection's already been made. Then you just decode the cookie to find out what that origin is and just send them there. If a cookie is not present, then you look to see which of these two origins you want to send them to and probably send them there. Either the origin sets the cookie or you can do it in the origin response, whichever works for you. This is typically, so the way you do that in the origin request event is by modifying the origin that was originally, it's the way it's set up in your config. So in CloudFront config, you always have to provide an origin. That origin will be passed to the function as part of the request object. So in the request object, if you see request.origin is where you would have the details of the origin, and you can modify all properties of that origin. And you can even move from an S3 origin to a custom origin if you so choose. And this modified origin should be returned as part of the request that you hand back to CloudFront, and then CloudFront will know what to do with it. It will now make a connection or use an existing connection to this new origin, and will just continue with that request. So like we talked about using a cookie, I'm just showing an example of a A/B testing. We want to hold off questions till the very end if you don't mind. Thank you. So in this case, what we have here is on the right, we have the decide logic, which is pretty straightforward. It looks for the presence of the cookie. If it's there, uses it. If it's not there, decides on a new origin. And then whatever it returns back is the desired origin that you want to send this request to. And then in this example, we go then update the domain name, because that's the only property we are changing, because all origins for our example look identical. So we update the desired origin as the domain that we want to go to. The one thing of note is that if you most times it's preferable that the host header be the same as the domain that you're reaching out to. But there are use cases where customers desire sometimes for them to be different for a variety of reasons. So both are possible. It's preferable. If your origin expects it to be the same, then make sure to update that as well. And once you do that and return back, then it's like any other request that came in the door for CloudFront. It continues processing it just the way it used to. Now, let's come to the third topic that we talked about, which is the response generation at the edge. This can be done both in the viewer request and the origin request event. The big difference between the two is that whatever generated in the origin request event is cacheable, because it will go through the CloudFront cache before it gets to the viewer. But the viewer, whatever you generate in the viewer request event is not. It goes directly back to the viewer, and that's how it would look. Actually, if I extend this picture a little bit, there's really no origin in this case, because all of the responses are being generated at the edge. Cool. Just reiterating what we talked about, it can be done in both places. What you generate is a complete HTTP response, including the status and all of those, and we will see examples of how to do that. And then in the request, up till this point, we've been calling back or returning to CloudFront the modified request. So if you guys remember, in the origin request and the viewer request, we always had callback null comma request. That one changes here. If you are generating a response at the edge, then you generate that response, which is a full HTTP response, and you return that generated response. And that's the signal for CloudFront to know that, okay, this one's actually a generated response in the request event, and then it knows that it doesn't have to reach out to the origin or even look in cache and just serve this generated response. That's one key difference between what we were doing up till this point and what this allows you to do. Cool. So when you are generating responses, there's two. I mean, I wouldn't say these are categories. It's just how the cookie crumbles in some ways. So you may have cases where you don't have to generate a body, where this mostly applies to redirects, where you get in a request and you know you need to send this request out to a different domain or whatever your setup is. And then you just generate that 302 right away and send it off. And these 302s are cacheable, so you can do it in both viewer request and origin request. Where it gets exciting is when you are actually generating a response with body, and it's possible. There's many ways you can approach this. One is where you are taking a collection of highly cacheable items, and you are now composing them together, which is unique to this particular viewer. Or sometimes it is also possible that you go look it up in a database, and you know who that user is, you get something about that user, use that to generate your response. And all of these are possible from both viewer request and origin request. So let's take a quick look at redirects. It's doable from both these events like we talked about. There's no origin in this case. I forgot to delete it from this picture. And this gets sent out. So this is an example of how a fully generated response looks like. You set the status code, you set the description, you set whatever headers you want to set. And in redirect, there's really no body. So you don't set a body, and then you would return this response back to CloudFront, and that's the signal for CloudFront to know that it's a generated response, which it takes and sends out. Let's look at a little bit more involved use case where you want to aggregate some content. The particular example that I have picked is something we have some sample code for as a blueprint for a function. What we are doing in this example is the user, let's say this is the landing page for your weather app where you have a list of cities that you're interested in. All it displays is a summary of the weather for that day. And the list of cities for you may be different from the list of cities for me, and it varies, right? So the client would make a request with the list of cities in the URL. And each city's weather is highly cacheable, at least for the next 15 minutes. It's probably not going to change. But the particular combination may still be unique. So you could potentially pull these highly cacheable items from the CloudFront Cache, from inside your function, compose a response, and send it back out to this particular viewer. And that's the example we're going to look at. There's two parts to it. One is how you fetch the content. There's not a whole lot that's interesting here. All that, if you see in the middle, there's a couple of splits. That's to split the URI to get the list of cities that you care about. And the promise is a Node.js framework for you to make some asynchronous calls in parallel. And this code now sends off a bunch of queries, essentially to CloudFront objects, to fetch some content. And here's where we put that stuff together. So for all the ones that we got a successful response, we would just create a body. In my case, I'm just collecting them all as a JSON, which I assume the client knows how to interpret. There's nothing stopping us from generating a full-blown HTML in here, which I'll show in a later example. And then once you generate this response, you would return that back like we've been talking about, and that gets served. Okay. Cool. So coming back to our the example that we've been using, now we can see how some of these dynamic content have been, or it's possible that some of these dynamic content can be generated at the edge. We've seen examples of how you can probably use a combination of highly cacheable items to generate something that's unique to that user. Now let's get into how can we take advantage of knowing who that user is or knowing something about that user and how that could help. Yeah, essentially this is reiterating the message that we moved compute closer to the user, and this has helped us with stateless compute up to this point. All the examples up to this point are sort of stateless in the sense that you look at a request, it tells you something interesting, and then you use that information to do some customization. You have not really paid attention to who that user may be. So let's jump right into it. Personalization is what I'm calling it. It involves knowing two things. One, who the user is, that's the authentication part, and then the information that that user carries with them, which is something interesting about that user. Sometimes it could be preferences, browsing history, buying history. You combine these two to provide a richer experience for that customer. The authentication mechanisms, so the three that I can think of, one is what CloudFront natively supports. We're not taking a look at that one for LambdaEdge. We're focusing on the other next two. One is authentication at the edge, where you can actually do the validation in the function. Typically, it's done with cookies, where the code knows how to interpret the cookie and then decide if this is still a valid cookie and whether to serve the request or not. The other option is the secret always resides in some place that you trust, and you can call out to these places from the viewer request or the origin request function. So as before you serve any content, you can decide whether to serve by calling out to one of your servers. So the way you do that is by making a network call, and this is supported from both these events. The accessing data for functions is a little bit more interesting. I'd say it's still evolving, and that's probably why you're seeing many options here, and some use cases benefit from some of these options better than others. One option is obviously to bundle it with the code, but it's a fairly limiting one. Even though it's easy to access and fast, it's probably requires you to deploy every time you change it, and it's probably limited by the size of the deploy package, and it's definitely read-only. You could go a little bit further and maybe use CloudFront Cache as a way of storing some read-only data. That again is, obviously one of the advantages is that it pushes the data closer to the functions, but on the flip side, it's read-only. The benefit you get, I guess I'm going back and forth. So on the plus side, it's closer to the function, and it can be refreshed periodically. On the flip side, it's read-only. This brings us to the database offerings, which is where you truly start to get the read-write that a lot of people want to be able to do from these functions. And here we have I'd say a wide variety of choices. If you pick regional databases, you get both SQL and NoSQL, but they tend to be regional, meaning it's further away from the function, especially for global execution. But with global tables being introduced, maybe that gap is starting to bridge, where you start to have replicated data that's multi-master, that's available closer and closer to these functions. So I'd say the options here are good in the sense that it gives you choice to decide based on your use case what would be the right setup for your current need. And as things evolve, hopefully by this time next year, we'd be able to give a much better answer of, hey, you can do all of these from this function. So we'll watch and see how that goes. Cool. So let me dive a little bit deeper into just doing content generation. And in this case, I'm going to just access DynamoDB from one of these functions, get something about the user, use that to construct a response and send it back out. The code is, there's nothing different. If you use Dynamo, then you already know what I'm doing there. There's nothing exciting other than that. It's all happening within the function. The one key thing that I would point out is that since these functions can run anywhere in the world, you need to be specific about the endpoint that you're getting to. If you do not specify the region, then Lambda tends to pick the local region and tries to contact the Dynamo in that one. So if you don't have Dynamo replicated everywhere, then you probably need to specify which region it is in. But otherwise, you go get the item, and then based on that, you generate a response. Pretty straightforward. And then once you've generated it, you would again do the callback for response, and CloudFront then continues processing it. Cool. I guess with this, hopefully we've motivated you guys that LambdaEdge can help with accelerating content closer to the user and maybe producing this content closer to the user. Let's take a quick look at something that I put together as a way of showing how this can be done. All right, give me a second while I get set up. I guess it's HDMI 2. All right, okay. All right, so what I have here is nothing special. I was going to call it the simple sharing service. What I have is a way for people to share some photos. I'd rather not answer. So, cool. So this is something I took on a hike near Seattle. I'm from there. This index.html is rendered from an origin request event. It is a completely serverless website. All I'm using is S3, CloudFront, LambdaEdge, and DynamoDB. Let's make this a little bit more interesting. Let's upload a few more pictures that I have, see what happens. Hope it all works. All right, seems like the first one went through, second one went through. Okay, cool. It uploaded all three. Then I go to refresh the page. It's going over my VPN. So now these guys all showed up on my web page. They are the recent ones. If we peer into this a little bit, let me see. So this is what my CloudFront distribution looks like. It's got what we call 3 cache behaviors. So I have one for index.html, one for the uploads, which is the API that I'm using to upload content in, and another one that's default that I'm mostly using to serve static content. So if we look at index.html, then I have it associated with a Lambda function for the origin request. And that's how that page is being rendered right now. Let's go look at what that function does. Let's see, where's Lambda? There it is. Okay, cool. Where is this guy? Index. Okay, there you go. Qualifiers, versions, I think 7. All right, cool. So what this code does is a few things. One is it's looking at a Dynamo table called reInvent 2017 pictures, and it's just scanning it for the top 6 items or the most recent 6 items, and then uses that to populate an HTML page. I mean, I don't know if in the fullness of time, I probably wouldn't have done it this way. I would have picked up a template, I would have populated that template and sent it out. Because I was hacking it together, I just said, okay, screw this, let's put it all in here. And that's what this does. So there's a header, there's a footer, and this is the place where I'm constructing the list of references, and then I send it back out once it's done with the header and set in some header values here. So this is the index.html. What's interesting about the upload part is that there's 2 things that happen on the upload path. One is that I A, write a file into S3, and B, create an entry for this in DynamoDB. That's what this index.html is reading. It's reading the DynamoDB. So for every successful S3 upload, I want to create an entry in Dynamo. And if I refresh this, you'll probably see the entries that it's created. On the upload side, there's 2 things I do. One is that I change the name that I uploaded it with. If you look here, the file name, or maybe I should go to the S3 page. Okay, there you go. So upload. There are no objects under this path. Maybe I should refresh it. All right, so if you look at it, I changed the names to some GUID. And this I do in my origin request event. Let me see if I can show you that function. So upload. All right, so this is the origin request. And in here, I generate a GUID, and then I set that as the URI in this part here. I set that as the URI. If I select this one, and then once I've set it, I reset the request, and I also include the metadata that I want stored in the object for future reference. And then I now send this request out to S3. And similarly, in the origin response, I do something very similar, where I look at, for every successful response that comes through, I look to see what that metadata was, if it was set. So I use this metadata, and then I add an entry in Dynamo, which is the code that we saw before. So I initialize my Dynamo, and then I call this table to update and include this entry. So once I do this update, then the index.html will, whenever it refreshes, will rescan and produce a new page. This is pretty much all I had for the demo. This is mostly to illustrate that something as simple as this, which I hacked together in a day, can be done all with LambdaEdge. Even though this looks like a very toy example, it's got some serious underpinnings where you're able to produce what looks more like an API and support it all from the edge, and similarly, basically look at databases and use that to produce content that's specific to that particular user. And this can be quickly extended to include per user and private and public and all of that stuff. Coming back to where we started, we started out by adding CloudFront, which helped move highly cacheable content to the edge, and then we showed you how we've moved compute with LambdaEdge to to a location that's closer to the viewer, and how that helps with stateless compute, where you look at the request and are able to decide the list of things that you want to do. And then we have showed that how data can be moved closer to these functions. It is still an evolution, it's ongoing, and more exciting things are to come, but it's still possible today to do some interesting things. And we believe that the combination of these three things, moving closer to the user to is a big change in how we used to do things, and hopefully it motivates people to build on using Lambda at the edge. That pretty much brings us to the end of our talk. We'd be happy to hang out here. If you guys have any questions, feel free to come up. And thank you very much for taking the time out to talk to us.